Okay, hello and welcome to this session of proof antics. I think today I'm talking about my PhD thesis. By the way, my name is RK Aqua. I'll be talking about my PhD thesis in a brief moment. This thesis actually took a while to put everything together. I think about how should I put it? I think it was done around 2017, and I was able to defend it around 2021. Or two rather, 2022 rather. So you can see the time interval. The time I started even PhD was different. The time I actually did was around 2017, and then the time I got to defend it was 2022. I think it has an issue with it being simple yet not already being known or something like so. As I go through, you see how it is. So if you are pure mathematician lover, whether in topology, algebra, group theory, and things like that, then you would enjoy this method I'm going to discuss. Now, the method I'm going to discuss is okay. Before that, I think I have my thesis on ResearchGate. I think the publication is not ready yet, so I have the whole thesis on ResearchGate. If someone requests, I might put the link here, but I think when you go to ResearchGate, you should be able to see it if you are looking at the screen now. Okay. That will be that part. So in case you want to read the full thesis, I think the contribution in it is two parts. One is in pure math and the other part is computing. So how in specifically automated proving, how the methods that are being used there. I used this method to develop a new method there where and then I kind of a new method that I used to prove theories in automated way to I think there's this method called resolution. Those that are in that field will know. I kind of develop another method for that, so I think that's a different matter for now. But for now, let's talk about the proof by tautology. I think if you have seen the methods of proof that we do proof by contradiction, and now I'm going to discuss proof by tautology. The method is not that difficult if you see how mathematicians, the kind of proofs that you normally do. The theorems normally comes in this form. You have a proposition. It might be many or just one proposition, and then you want to it links to some kind of conclusion. So meaning you have some conditions that you need to satisfy for the P, and then when those are satisfied, you can safely logically imply that the Q, the conclusion, will also follow. And most theorems are in this form. And the theorems that have been, the methods of proof that are being used are basically direct method and then the indirect method. The direct method, we have only one, I think it's also called direct method. And then the indirect method, you have contraposition and then contradiction. So I'm going to discuss tautology, proof by tautology here. Tautology. Okay, now I think if you know the truth table for my lines are bad. Truth table. So if you had P and Q, and then you wanted to do P implies Q, I think you could have something like true, false, and this should be true, false, something like that. Now, when the hypothesis is true, that's T is true, and then the conclusion is also true, the implication will automatically be true. Okay, so you have something like that. But if you have all the conditions satisfied but the conclusion doesn't follow, you have false, any other thing is true, because if you have the conditions not specified being false, then yeah, whatever implies will follow. So that one will be true. I think this is the truth table that you have. I think my diagrams or my writing is really bad. It's been long since I used this thing. So, but I think when you are assuming you are doing tautology, when you are doing contradiction, this is what you do. You assume that the P implies Q is false. So you assume this one is false. So this line is what you do for contradiction. However, if I'm going to do tautology, I'm going to do all these ones. I'm going to assume that it is true. This is my assumption. This is for tautology. So this is the assumption that you made. So you assume that P implies Q is actually true. Now, if you assume that it is true by the logical equivalence of P implies Q, we can have something like not P or Q, meaning P implies Q is equivalent to. So you can use this logical equivalence, says that P implies Q is logically equivalent to not P or Q. So I could use this thing here. So since I'm assuming this is to be true, then I can use any of this. Meaning, this is my assumption, and I have to show that there's a tautology. Now, if you remember, contradiction, when we assumed the false, we have to deduce a contradiction. A contradiction for the contradiction. So you assume this one is false, and then you show contradiction. With tautology, we assumed it is true, and we show that there's a tautology. And tautology comes in this contradiction that was coming in this form. If you are assuming this to be false, you show that the contradiction is the same P. Sorry. Not P or Q. So this would be a contradiction. So when we want to show tautology, we do something similar. We have to show something like not P or P. So you have to get this thing, meaning a system where both of this statement is true. And if you had this already, then we will try and get this. So if you see what our assumption is, we assumed this to either not P or Q. So if I start from not, okay, let me get a different page or something. If I start from not P, that's this one. If I start from here, not P, then I have to use this Q here to deduce the P, so that I'll get not P or Q, and that will be a tautology. Now, if I decide to use the Q, then I can go from the Q, or then I have to use the not P to deduce the not Q, so that I also have a tautology. It's tautology here also. So that's the two main way you can go, but there's a different way that you can also go about it, which is to deduce from the assumption not P or Q some C. So let's call this C some proposition. So if I deduce that proposition, then I also deduce not of C. So we could get something that is not in the P and Q, but we are using a different thing to get another tautology here. So we could use a whole different proposition from the not P and Q, but it has to be an implication or some logical from deduction from the P or the Q, the not P or the Q. So that's how we go about doing the method tautology. Okay. Now, I say a few things about it that whilst contradiction cease to deny, here we are trying to actually affirm. So you assume something and you affirm it, you confirm it or affirm it. That's true. So that's the method of proof by tautology.